Today we are starting tree diagrams. So we're going to do some basic tree diagrams today. We're going to talk about when we have replacements and when we have non-replacements. And then we're going to hopefully do some trickier ones next week, Tuesday. But we're just going to introduce ourselves to tree diagrams today, start understanding how they work, and then we'll go from there. So first one we're going to do is we're not going to do a tree diagram to start off. We're going to do a table. So that's our first little goal that we're going to do over here. Even though we're learning about tree diagrams today, just keeping things spicy. So what we're going to do is we're going to do like a contingency table type thing. So let's have a read of our question. We have a sports team and they have 3 sweaters. So they've got a white sweater, a gray sweater, or a black sweater. So a white one, a gray one, or a black one. And they've got 2 pants, white pants and black pants. The sweaters are placed in one box and the pants are placed in another. And then the captain chooses one color from the sweater box and one color from the pants box. Make a list or a table of all the possible outcomes. So what we've got going these are our sweaters. So we've got 3 options for our sweaters. We've got white, gray, and black. And then we have our pants. So I'm going to call this white pants, black pants, so that I know what I'm talking about. Okay, this is my contingency table. So if I'm wanting to figure out what my whole sample space is, so I want to know what all my different options are, all we have to do is we have to kind of do it step by step. So this option would be saying we've taken the white sweater with the white pants. This one is the gray sweater with the white pants, and this is the black sweater with the white pants. Then we have white sweater with black pants, gray sweater with black pants, and black sweater with black pants. So my first question to you, don't know why I'm doing a capital N, is what is my sample space? What is that going to be equal to? How many different outcomes do we have? Yeah, we've got 6 different outcomes. We've got outcome 1, outcome 2, outcome 3, outcome 4, outcome 5, outcome 6. 6 outcomes. Why are you crying, Sanele? It was right. Oh, thank you. Just didn't straighten my hair. No, you're not wrong. You're right. So now when we look at the next question, it says, what are the chances of the captain choosing a black sweater and black pants? So then we have a look at our sample space and we see where is there an option for a black sweater and black pants. And the only option is this one over here. So what would be the probability of the captain choosing that? So the probability of choosing a black sweater and black pants. Good. Exactly. 1 out of 6. So that is my favorable outcome. That's the one that we want. and that is our total sample space. All right. Does anyone have any questions about that? Please feel free to ask if you do. Okay, good. Okay. So instead of drawing a contingency table, we could have put this into a tree diagram, which is what we're going to look at now. So tree diagrams are when we're trying to look at more than one thing that is happening. So we've got a nice little tree. So if we drew this as a tree diagram, what we do is we put our different options at the end. So these are the different options. So choosing a sweater, I've got option 1, which was the white sweater, option 2, which was the gray sweater, and option 3, which was the black sweater. Okay. On the line of the tree, we put the probability of that happening. And this is the option. So because there were 3 sweaters, I have a 1/3 chance of picking each one of those. So I've got 1/3, 1/3, 1/3. So on the tree, we put the probability. Then tree diagrams look at progression. So they're saying, okay, if I picked a white sweater first, so I first picked a white sweater, and now I had to pick pants. I could either pick white pants or I could pick black pants. So I already have a white sweater, and then I could either pick white pants or I could pick black pants. And so because I've got 2 different types of pants, I'm going to have a half of a probability of picking each of those. So that's what's happening here. In this situation, this person has first picked a gray sweater and then picks white pants. That's this outcome. Or picks a gray sweater and then picks black pants. That's that outcome. So we follow on the different outcomes that we have. Does that make sense? Hopefully. Okay. When we add up all of these together, we should get 1. Otherwise, we have done something wrong. Okay. Using the tree diagram, calculate the probability of choosing a gray sweater and white pants. So what we do is we follow on our little path. So I'm just going to erase those for the moment. So we follow on our path. The first path is that we picked a gray sweater. So we pick a gray sweater. That's path 1. So the chance of picking a gray sweater is 1/3. Then I'm picking white pants. So my second journey is picking white pants. When we move across a tree, we multiply. So when we move from one branch into the other, we multiply. So we're going to say 1/3 times 1/2, and that is going to give us 1/6. So there is 1/6 of a chance of us picking the gray sweater and the white pants. All right. Can you answer D for me, please? Keep those answers coming. So using the tree diagram, calculate the probability of choosing a gray sweater and white pants, or a gray sweater and black pants. So we've got two different options here. Option one is a gray sweater and white pants. So gray sweater and white pants. That's this one over here. And option two is gray sweater and black pants. So gray sweater and black pants. So that's that option over there. So when we have two, when we're working this way, if we're wanting to look at multiple things, then we're going to add them. So we're going to say, okay, we have a sixth plus a sixth, which gives us 2/6, which gives us a third. You can leave it as 2/6, so if you want to. Okay. Yay. And now I'm going to give you a really easy one to start filling in. And then we're slowly going to get a little bit harder each time. If you would like to take a screenshot, please feel free. Oh, that's so sneaky, Abu. Yeah, tree diagrams can be ambiguous. It happens often in the questions. Okay. So below is a tree diagram illustrating two coin tosses. So what you need to do is you need to fill in your probabilities. So all of these little boxes, there needs to be probabilities. And then you need to do this final probability. So it will be the one probability times the other probability, which will give you your final probability. Okay. Be free. Draw out your tree diagrams. All over the place. Okay, 1 more minute. Finish up your tree diagram. Great answers. Get them in. Some good news. Let's see, you won a competition and you're representing your province as well as you won a 3-year bursary. Oh my goodness, along with a tablet, a voucher, and 40,000 Rand in University Senele. That is amazing. Wow, well done. That's huge. Congratulations. What competition did you win? Oh man, I'm so proud of you. Well done. I Googled it, and it says, just so we all know how to be equally like as impressed with Sanele as we should be, it's the Financial Literacy Speech Competition, and it offers life-changing prizes for South Africa's brightest grade 11 minds. So there you go. We've got one of South Africa's brightest grade 11 minds with us in this class. Nice job. Well done. Okay, I'm going to fill in my tree diagram. So when I have a coin, I could either get heads or I could get tails. So I have a half of a chance of flipping each of them. And then again, I would have a half of a chance. So my probability of getting heads and then heads would be a half times a half, which is going to give me a quarter. And it'll be exactly the same for the others. And so now we know what our different probabilities are. Then we can start answering some questions. If I tossed a coin, what is the chance of getting a tail? So just in general, if I tossed a coin, what is the chance of getting a tail? Any coin, just toss it up. Except Abu's coins, none of Abu's coins. Yeah, we have half a chance of getting a tail. Cool. If that coin, so now we've tossed that one coin and we got a tail. If that coin is tossed again, what is the chance of getting a second tail in a row? So what we've done is this first question is saying, cool, what's the chance of us getting a tail on our first flip? Now we're flipping it again. What is the chance of getting a second tail? So we're getting 2 tails in a row. So we can say, cool, well, that's going to be a half times a half, which gives us a quarter. No worries. Does it make sense why it's a quarter though? Okay. Now we're going to get into some of our English questions. What is the probability of getting at least one head after tossing the coin twice? I'll read that again. What is the probability of getting at least one head after tossing the coin twice? Abu, are you sure? Let's see. So when it said at least one head, let's have a look. This one has 1, so we can include it. So that's a quarter. This one has 1, so we can include it. That's a quarter. This one has 2, and the question said at least 1. 2 is at least 1, so we can include it. This one doesn't have any heads. So the probability of getting at least one head after tossing the coin twice is going to be a quarter plus a quarter plus a quarter, which is 3 quarters. And the last question. Just going to pop this up here. I'm going to quickly go turn on the lights while you answer this one. What is the probability of getting 5 tails in a row? 5 tails in a row? Does seem like a low chance, doesn't it? So the probability of getting 5 tails in a row, what we're going to be doing is we're going to say, well, cool, that's going to be a half times a half times a half times a half times a half, because each one of those is going to be a flip. And that's going to give me 1 out of 32. So it's possible, but the chance is low of getting 5 tails in a row. What if I said, what's the probability of getting 100 tails in a row? What would be an easier way for me to do this than to times all of them? What would be an easier way for me to write this half times a half times a half times a half? How else can I write this? How do you write something if you say like 2 times 2? What's a different way of writing 2 times 2? Yeah, exactly. A half to the power of 5 will give us 1 over 32. So if I wanted to know 100 in a row, I would say half to the power of 100. And you'll get a huge number as a denominator, but it will be a tiny, tiny fraction. Okay. I'm just going to zoom out a little bit so you've got the whole question. If you want a screenshot, feel free. Okay, cool. Next one, slightly different. You are one of the finalists in a game show called Spin and Win. There are 5 possible prizes. You spin the top arrow to decide the prize. So whatever it lands on, that's the prize. And then the bottom arrow to either win or lose the prize. So this would be your tree diagram. Can you please fill in your probabilities? So we're leveling up 1 level up here. So this is now just a touch bit harder. Just going to give you a couple minutes to do this. So think about how many different options are there? So what would be the probability of getting each of these? And then think about how many options there are here. And so then what would be that? So you can either win a soccer ball or headphones or an iPod. I don't think iPods even exist anymore. I still have my iPod. Do people buy iPods anymore? Or do they not really exist? Is that like a thing for old people? Because we just have it all on our phone, I guess. Or you could win a chess set, or you could win a computer. Let's make this an iPad then. So you can choose. So I normally use like the first letters. So I would say S, H, and then I, C, and then maybe C, O. But you must use ones that you feel comfortable with. So I would call this H, I, C, C, O, S. Well, Abu, we can change the chase set to boxing gloves for you. Okay, 2 more minutes. It's okay. Okay, so now this one's the reason this one's slightly different to the heads and tails is that I don't only have 2 options. I now have 5 different options for my first time round. So each of these I have a 1 in 5 probability of spinning that on the wheel. Then let's say I had spun to get the headsets. I now either will win or I will lose. So I now have a 50-50 chance of winning or losing. So these are all going to be a half. And so then when I multiply them, we remember we multiply this way. So I'm saying the probability of getting headsets and then a win will be 1/5 times 1/2, which is 1/10. The probability of getting headsets and losing will be 1/10. An iPod and winning, 1/10. And losing, 1/10. So all of these dudes will be 1/10.
Ma'am, can you please re-explain, ma'am? I'm kind of lost.
Absolutely. Where are you feeling lost with it? The whole thing.
Yes, ma'am.
Okay, no problem. So basically what's happening here is that when we have a tree diagram, the first option is we have to look at how many different options we have, and then that tells us what the probability would be. So if we're looking at this like spinning wheel type situation and we spun the wheel, it's going to land on one of them. So it could land on one of the 5. So I've got 5 different options. So if I have 5 options and they all have an equal chance of landing on that, each of them will have a 1/5 probability of being spun. Okay, so that's the first part of the game show. So we've spun the wheel. We have a 1 in 5 chance of picking something, and that's the first part. The second part of the game show is now we spin a second wheel, and that wheel, it's either going to be win or it's going to be lose. So if we follow the journey of one of these, I'm just going to do this first journey over here. This is imagining that you went up at the front of the game show, you spun the first wheel, and you landed on headsets. Then you spin the second wheel and you landed on win. When we work from one branch into another, we always multiply our probabilities because we're saying that 2 things have had to happen in order for this outcome to happen. So the probability of you first spinning a headset and then spinning a win is going to be the probability of the first one times the probability of the second one, which just gives us 1/10. Now, all of these are just the same numbers. They're all 1/5 times 1/2. So that's why we know all of these are just going to be 1/10. Does that make a bit more sense?
Yes, ma'am. Thank you, ma'am.
Anytime. Okay, so let's carry on filling this in. So this is the probability of a computer and a win, and the probability of spinning a computer and losing. Hi, why are you here so late? What happened? Okay, that's fine. Okay, if you are the first person to compete, what are your chances of winning a prize? What are your chances of winning a prize? So have a look at your outcomes and look at the ones where we win something. So we win something here, and we win something here, and we win something here, and here, and here. And when we're working this way, we add those probabilities. So look at all the yellow boxes, add all of those yellow boxes together. So all of those boxes are ones where we've had a possible win. Yeah, there we go. So we just have to add those all together. So we have a 10th plus 10th plus 10th plus 10th plus 10th, which gives us 5 out of 10 or a half. You have half chance of winning something. Oh, you're writing maths tomorrow. Exciting. Lots of 10ths. There are lots of 10ths on this page. What are your chances of winning a computer? So now look at all of your outcomes. So these over here, these are our outcomes. And look for the favorable outcome and see how many favorable outcomes there are. What is the chance of winning the computer? Yeah, so we look for the computer. So they've spun for the computer and then they've spun for a win. So it's this dude over here. That's my favorable outcome. So the probability of getting a computer and then a win is going to be 1 out of 10. Technically, yes, you are technically correct. Okay, last question on this one. If you win the computer, what is the chance that another person will win any one of the remaining prizes? The spinner remains the same and the computer is not replaced, but if you land on the computer, you can spin again. Think it through. I'm going to give you a couple more minutes to think. It is one of those Englishy questions. It's being tricksy. I actually haven't seen the answer that I'm looking for yet. Oh, hold on. I have seen the answer I'm looking for. Sort of. Ish. It's same, but different. Okay. So the trick with this question was it said, if you landed on the computer, you could spin again, right? So that essentially means that the computer is not part of our situation anymore. So now, when we're looking at our options here, what is the chance of winning? We now have 1, 2, 3, 4. Cool. But we don't have 10 options anymore. We only have 8 options. Do you see? So we have 4 of the 8 options where we would win. 4 of the 8 options, which means you still have a half a chance of winning. It was sneaky, but it's a higher order question, this one. It would have been like a 1 mark question. Yeah. It was very sneaky. No, don't hate on tree diagrams. Okay. So the next tree diagram is when we have replacement. So basically, like if I have something and I'm going to put it back, so my numbers aren't changing. Remember when we did that card question and we pulled the card and then it changed the number of cards. So instead of out of 52, it became 51. When we're not replacing, then that happens, but this one is going to be with replacement. So Batman always carries his weapons in a bag in the Batmobile. In that bag, he carries 5 stun grenades and 3 nets. So we have G and N. Okay. As soon as he uses an item, Robin immediately replaces it. So there are always 5 stun grenades and 3 nets. So that's telling us that things are being replaced. Batman just picks an item from the bag and throws it towards the villain each time. He does not know which item it is until that item is thrown. So now let's look at our probabilities, because this is one step harder. How many weapons does he have in total if he has 5 stun grenades and 3 nets? Good. Okay, so we've got 5 stun grenades and we've got 3 nets. Using this that we've just written up here, what would be the probability that he pulls out a grenade if I have 8 weapons in total, 5 grenades and 3 nets? What's the probability that he's going to pull out a grenade? Good. 5 out of 8. Excellent. What's the probability that he's going to pull out a net? Good. Now, after he's pulled these out, Robin has immediately replaced them. So they are back to having 8. So his second weapon, again, he has a 5 out of 8 chance of getting a grenade or 3 out of 8 chance of getting a net. So I want you to finish this one off. So you've got your last 2 probabilities, and then I want you to finish this part here. 2 more minutes. Okay, let's have a look. Yes, earthly minutes. I feel like I've been good lately with my minutes. Have I not? I've been trying really hard. Okay, thank you. Okay, so when we work from one branch to another, we multiply. So we're going to say 5, 8 times 5 over 8, which is going to give us 25 over 64. And our next one, we have 5 over 8 times 3 over 8. So that's going to give us 15 over 64. And then this is going to be 5 over 8. So we're going to have 3 over 8 times 5 over 8, which is 15 over 64. And this will be 3 over 8. So 3 over 8 times 3 over 8, which will be 9 out of 64. How did that go? Are we yaying? Are we naying? Where are we at? Are we happy? Full marks. Okay. Okay. You don't get it. What do you not get, Tuyanda? The second weapon. Because all of the weapons were replaced. So the probability is going to be the same the second time. So all that this is doing is looking at a progression of things. So for example, this option here, that's saying that my first weapon was a net, and then my second weapon was a grenade. So the probability of first getting a net was 3 over 8, and getting the second weapon was 5 over 8 because they were replaced. And there were 5 grenades. If they're not replaced, which is what we're going to do next, then that changes. But because they replaced, those probabilities stay the same. And then when we want the final probability, we just multiplying those together. Okay. All right. Give these 2 questions a try. Okay, probability of throwing 2 nets. That would be this dude over here. Probability of throwing 2 nets. So the probability of throwing 2 nets, net, and then a net is 9 out of 64. One of each weapon in either order. Okay, so that would be this one, because that's a grenade and then a net. And this one, which is a net and then a grenade. And remember, when we looking at multiple ones on the same, we add them. So that's 15 out of 64 plus 15 out of 64, which gives us 30 out of 100. Oh, hold on. No, I'm adding my denominators like a nincompoop. So when we're working from branch to branch, so like this way, then we multiply. But if we have multiple favorable options that are in this line over here, then we add them. Then we add those ones together. Okay. One last concept for the night, and then you can turn your brains off. You do have a quiz this evening, but after the quiz. If you'd like to take a screenshot, please feel free. Okay. Oh, because they said one of each weapon in each order, in either order. And this one has 2 nets and this has 2 grenades. So there isn't one of each weapon. There's 2 of the same weapon. Yeah, 9 plus 25 is wrong because that's looking at ones where there would be the same weapon. So that would be, what would be the probability that he pulled the same weapon both times? Then it would be 9 plus 25. Okay, so now we're going to look at without replacement. So this is now saying if we have used the weapon, then we've used it. So it doesn't get replaced. So in this situation, we have got 4 missiles and 3 electro pulses. So we have 7 weapons in total, and they cannot be replaced. Okay. So for my first throw of my weapon, what is the probability of me throwing a missile? 4 missiles, 3 electro pulses. What is the probability of me throwing? Exactly 4 out of 7. Good. And what is the probability of me using an electro pulse? 3 out of 7. Good. Okay. This is where it gets sneaky. So we're not replacing it. Okay, so now I've used a missile. That means that I only have 6 weapons left because I've already used one and I've used a missile. So what's my probability now of throwing a missile? Three out of 6. Good, because I've used one of them. I haven't used any of my pulses, so I still have all 3 pulses. So I still have 3 out of 6. In this one, I've now used a pulse, which means I still have 4 out of 6 missiles, and I would have 2 out of 6 pulses because I've used one of those pulses. So now my probability of using a missile is going to be 4/7 times 3/6. I'm just going to leave the questions up here as well so that you can see them. That's all we need to do tonight. So now if we had to look at these questions, what is the probability that Iron Man uses 2 missiles? So if we look over here, that's the only probability where he uses 2 missiles. So my probability will be 12 out of 42. And if you're feeling a little bit lost with tree diagrams, don't worry. Remember, we still have our lesson on Tuesday to do lesson number 2 on tree diagrams. We're going to draw more of our own on Tuesday. Okay, B, at least 1 electropulse. So that means at least 1. So that has 1 pulse, so I can include it. That has 1 pulse, so I can include it. That has 2, which is at least 1, so I can include it. So we're going to say 12/42 plus 12/42 plus 6/42, which is going to give us 30/42, which is 5/7, I think. Yeah. And then the last one is saying an electropulse and then a missile in that order. So we first need a P and then we need an M. So that's only going to be this one over here. So that means the probability of getting a pulse and then a missile is going to be 12/42. And that is a tree diagram without replacement.